Hey folks, so we're going to be looking at this topic of finding a reasonable domain and range. But before we can do that, we need to first actually brush up on number systems first. We can't actually determine what a reasonable domain and range is without knowing how to classify numbers. And the way that we classify numbers is we actually want to look within this real number system. Okay, so whenever I'm in high school math, I'm going to mainly focus on real numbers. So real numbers is a way to categorize a number that you have. And the nice thing about real numbers is that it's probably the broadest definition that we have. So if you think of any number in the world, like it could be the most crazy number in the world, that's going to be a real number, right? And within real numbers, we have two different groups. So we have irrational numbers and rational numbers, right? So irrational and rational, even though they're both different types of numbers, they're both real numbers because they're numbers that we can still think about, right? The biggest difference between rational numbers and irrational numbers is irrational numbers, you can't really predict what the next value is going to be. For rational numbers, we can reasonably predict what the next value is going to be. So let me give you an example, right? So one of the most famous examples of an irrational number is this number pi, right? You might have seen it before. It might look like a funny symbol if you've never seen it before, but this is representing a number. And the reason why we represent it with this letter pi is just because it's such a long number that no one has the time to write it all out, right? We actually don't know all of the digits within this number pi, right? So we can reasonably estimate that pi approximately is 3.141592654, on and on and on. Okay. When I'm looking at the numbers within this decimal, I'm not really seeing a pattern, right? This is why it's so hard to actually know what the next number for pi is going to be. This is why people can't just automatically come up with the next number of pi, right? There's no set pattern to this, and it goes on forever and ever and ever. It doesn't terminate. So I know that pi is going to be irrational because it's a little like irrational, right? Like I don't really know what it's going to do next. Another really common example of an irrational number is something like the square root of 2, right? So if you put the square root of 2 in your calculator and press enter, it's going to give you an approximate value, right? It's going to give you approximately 1.414213.562, on and on and on. Once again, if I'm looking at my decimals, right, I'm not really seeing a set pattern. Like I can't actually reasonably predict what that next value is going to be, right? So because I can't really predict what the next value is going to be within this decimal, I know that it's an irrational number because I don't know what it's going to look like 15 decimal places down the line, right? On the flip side, for rational numbers, it's any number that can be written as a fraction, or it's any kind of decimal where if it doesn't end, then it repeats a pattern in the decimal. So something that we can look at is let me get the example of something like 0.111 repeating, right? I know that the fifth decimal place is going to also have a 1, or the 75th decimal place is also going to have a 1, right? It's a pattern that I can very clearly notice. Other one might be something like 0.192 repeating, right? Because there's a pattern that's being established, I know that this is going to be a rational number because I can find some way of writing it as a fraction. Okay? So within my rational numbers, if I can categorize a number as being rational, I can possibly categorize it in a few different ways as well. So whenever I'm not dealing with a fraction, right, or not dealing with a decimal, I'm dealing with integers, whole numbers, or natural numbers, right? And the biggest difference between these is just very slight. So integers, it's any kind of like whole number, so like any number without a decimal, including 0 and negative numbers. So you might be wondering, why is 25 over 5 included under integers, right? So 25 over 5, if you actually simplify it, is the same as 25 divided by 5, which is 5, right? So because that can be written as a number without a decimal, I know that that's going to be an integer as well, right? So integers are just numbers without decimals, 0, and negative numbers, right? So positive numbers without decimals, 0, and then negative numbers without decimals. Whole numbers, right, are only looking at the non-negative versions of integers, right? So these are non-negative integers. Right? So this is why it's a subset of integers. So if you're a whole number, then you're definitely going to be an integer, because this is looking like 0, 1, 2, 3, 4, 5, 6, right? Because 0, 1, 2, 3, 4, 5, 6 are all integers, right? If you're a whole number, then you're definitely going to be an integer. The same goes for if you're an integer, you're definitely going to be a rational number, because you can always write integers as fractions. Now, natural numbers, right, are only the positive versions of whole numbers. So positive whole numbers. So this does not include 0. So the only numbers that are natural numbers are numbers like 1, 2, 3, 4, 5, 6, right? So if you're a natural number, then you're definitely going to be a whole number, because it's all the whole numbers except for 0, right? Except 0, okay? So now that we know what these different number systems are, why don't we actually try to classify numbers according to their number systems? So something that's important to note is that a number can be a part of multiple different number systems, right? Mainly because if you're a natural number, then you can definitely be a whole number, right? Because natural numbers are smaller subsets of whole numbers. In addition, if you're a whole number, you can also definitely be an integer. If you're an integer, you can definitely be a rational number. If you're a rational number, you're definitely going to be a real number. So numbers belong to multiple systems, right? So the way that we can actually classify our numbers is by doing a few tests, right? And so the first thing that we want to do is just analyze our number. And sometimes numbers are super easy to classify. So for example, this number 15, it's a positive number without a decimal, right? And so because it's a positive number without a decimal, I know that this could actually be a part of the natural group, right? I know that it's a rational number because I know that 15, it's not a decimal that goes on forever and ever and ever without a pattern, right? It's just 15. So I know that 15 is a natural number. This is probably the smallest circle that I could find 15 at, right? And once I find the smallest circle that this number belongs to, so in this case it belongs to the natural numbers, right? Then I can also classify it with any of the bigger circles, right? So I'm going to read up. So not only is 15 a natural number, 15 is also a whole number, an integer, a rational number, and a real number. So I can classify 15 as all of these different number systems. Let's look at my next value. I have negative 1.4583, and I just want to analyze that number. So I see that it has a decimal, but it's not repeating on and on and on, right? So because I have a terminating decimal, so let me just write that this is a terminating decimal, meaning that it definitively ends, right? I have a terminating decimal, and I know that I can classify terminating decimals as rational numbers, right? I know that it's not going to be classified as an integer, a whole number, or a natural number just because we do have this decimal value over here, right? So it can't be any of these number groups, but it can definitely be a rational number. So this is probably the smallest circle that I can classify this number into. So because I can classify it into rational numbers, I can just read up, and my next biggest circle is real number. So I'm going to classify this as a rational and a real number. Finally, let's look at our last example. So we have the square root of 57, right? And I need to analyze my number. I don't really know what the square root of 57 is, so I could try putting this into my calculator to try to figure out what approximately it is. And when I put this into my calculator, I get 7.54983, on and on, right? And there's no set pattern to the numbers that I'm seeing, right? I see 7.549834435. Okay, I can't predict what that next number is going to be. So it seems like I have an irrational number just based on putting it in the calculator. So I'm going to classify it as irrational, okay? Now, if we look at the irrational bubble here, right, there are no groups within the irrational bubble. Not like how there is with the rational bubble where we have integers, whole numbers, and natural numbers, right? If you're an irrational number, then you're just an irrational number, and you're also a real number if you read up, right? So I'm just going to classify square root of 57 as an irrational and a real number, right? If you're an irrational number, you cannot also be an integer, a whole number, or a natural number, right? You can only be irrational and real. So why don't we do a check for understanding? So take a minute to just pause the video here and try to actually classify these numbers according to the number systems that they belong to. Remember that numbers can belong to multiple systems, so you should try to figure out all the systems that this number could belong to. All right, you tried it? Let's check it out together. So the first thing that I want to look at is the square root of 25, right? So I want to analyze this number. And right now, I could just be looking at the square root of 25 and be like, what does that mean? So I can put this into my calculator by doing second x squared 25 and pressing enter, and I end up getting 5. So this is really equal to 5. Okay, so I'm not analyzing the square root of 25, I'm analyzing this number 5 because this is what it's equivalent to. And when I look at the number 5, I see that it's a number without a decimal, and it's a positive number. So I think the smallest group that 5 could fall under is the group of natural numbers. Okay, so I know it's a natural number, and all I have to do is read up. So not only is it a natural number, it's a whole number, integer, rational, and real. So it's a whole, integer, rational, and finally real. Let's look at my next example. I'm going to look at negative 32 over 95. So what I can do is I can put this into my calculator again. So if I put this into my calculator, negative 32 divided by 95, I end up getting a decimal. So I get negative 0.33684. But I want to just look at it at face value, right? Because if I put it into my calculator, I might think that this is an irrational number because I'm not seeing any kind of pattern to this decimal. When I look at this number, I notice that it's in fraction form, right? It's a ratio of 2 integers. And so, because it's a ratio to integers, or it's a fraction, I know that this is automatically going to be a rational number, because if I think back to my definition of a rational number, it's any number that can be written as a fraction. So I know that this is definitely going to be a rational number. And I know that it can't be a part of integers, whole numbers, or natural numbers, just because when I put it into my calculator, I end up getting a decimal, right? I'm not getting a number without a decimal, which you would need in order to be an integer, whole number, or natural number. So I know it's a rational number. That's the smallest group that it's going to be a part of. Now all I have to do is read up, and I see that my next biggest circle is real. So it's a rational and a real number. Finally, I have the square root of 2 over 3, right? And so I might be thinking, oh, okay, in my last example, 2 over 3 is a fraction, right? My last example was a fraction, so that's how I knew that it was a rational number. But I think it's important to note that you're not looking at 2 over 3, right? You're looking at the square root of 2 over 3, which is an entirely different number. So if we actually try putting that into our calculator, right, so we're going to do second x squared, or if you're in Desmos, then you would do SQRT. And then I'm going to do 2 divided by 3. And then this is the number that I get. So this number is actually 0.816496, on and on and on. And I'm not really seeing any kind of pattern to this decimal that keeps repeating. And so, because I'm not seeing a pattern to this decimal that goes on and on and on forever, that matches my definition for irrational numbers. So I'm going to classify this as an irrational number. And then all I have to do is read up. And I see that this is not only an irrational number, it's also a real number. All of these numbers are real numbers. Okay. So hopefully this was a little bit, hopefully this was helpful to you in terms of just learning how to classify numbers. This is going to be really important in order to learn about how to find a reasonable domain and range. So tune in for the next video where we're going to discuss how to actually do that.